Good morning, everyone. Let us start with today's session. So, this is lecture number 11 of the engineering mechanics. So, in this lecture, we will cover the general force system and the resultant calculation for the general force system. So, before that, we will cover the last problem on the parallel force system. So, this was the last problem where the excavator arm is subjected to a load of W, that is equal to 500 kg, and one cable is connected at the end A. This cable has tension T is equal to 6000 Newton, and we want to find out the resultant R, and we have to find out the location of the resultant with respect to point B. So this is the physical system, and this is the equivalent force diagram for this system. So the weight of this pipe, it is given as W, that is equal to 500 kg. So we can convert this weight in terms of a force. So force will be 500 into 9.81. So unit will be Newton. Now each cable will have the load or force which is equal to total force divided by the 4. So each cable will have a force of 1226.25 Newton. So we will show these forces. So consider this complete arm as a beam AB, which is represented here by a straight line. The angle of this arm, it is equal to 30° with respect to horizontal. So consider this force is acting at point C, second is at D, E and F. So value is same. So F is equal to, it is 1226.25 Newton, and this tension T, it is equal to 6000 Newton. So when we find out the resultant, we can consider this vertical axis as a y-axis and this horizontal axis as a x-axis. Okay, so all the forces, as they are acting only in the y direction, so there is no need to resolve the forces. So this is actually a parallel force system. So for the parallel force system, if all the forces are acting only in the y direction, then the resultant R, it can be given by the equation summation Fy only. So we have to use this equation, and then we can find out the resultant value. And to find out the distance of the resultant with respect to point B, we need to use the Varignon's theorem. Okay, so we will study this step by step. So just I will draw the beam AB. So this is the beam AB. Now distance between each point, it is given as 50 centimeter. Okay, so this will be 0.5 meter. And this is the tension in the cable, that is 6000 Newton. So resultant R is equal to summation Fy. So all these forces, they are acting in the negative y direction. So equation will be, this is minus F, or simply we can write down minus 4 into F and plus this 6000 Newton. So this is equal to minus 4 into F plus 6000. So F value, it is equal to 1226.25 plus 6000. Okay. So we will get the answer for the resultant. So this is equal to 1095 Newton. And as the answer is positive, that means your resultant R, it will act in the positive y direction, that is upward. Okay. So have you got the same answer? R is equal to 1095. Now to find out the location of the resultant, with respect to point B, we need to use the Varignan's theorem. So for the Varignan's theorem, the equation will be summation of moment by all the forces about the given point. So we want to find out the location with respect to point B. So we will take the summation of all the forces in the system about the point B. It is equal to moment by the resultant about the same point B. So this is the mathematical equation for the Varignan's theorem. Okay. So for the Varignan's theorem, we need to convert the force system into equivalent resultant system. Okay. So this is the force system. Just I will redraw this beam AB only. So this is the beam AB. So what is meaning of resultant system? Actually, we are replacing all these forces and we represent this force system by a single force. So that is called as a resultant system. So I will assume resultant in the upward direction. So this is the R, that is equal to 1095 Newton. So we don't know what is the exact distance of this resultant with respect to point B. Okay. So just assume the distance x on this beam with respect to point B. So by using Varignan's theorem, we will find out the distance x. So for that, I have just assumed x as a distance with respect to point B for this resultant. So now we will use the Varignan's theorem. So for the Varignan's theorem, first we have to find out the summation of the moment by individual force about the point B. So let us take 6000 Newton force and try to find out the moment of the 6000 Newton about the point B. Okay. So this is the 6000 acting at point A. For the moment by 6000 Newton about the point B, we will need a perpendicular distance with respect to point B. But the distance which is available from this diagram, is it perpendicular distance? So this distance, it is not a perpendicular distance. So total distance here given, this is 0.5, 0.5. Okay. So total will be 2.5. Okay. So total distance A to B along this line, it is equal to 2.5 meter. But this is not a perpendicular distance. So how to find out the perpendicular distance? Just extend this line from point B. Okay. And draw one perpendicular So that distance, it must be perpendicular to the force direction with respect to point B. Okay. Or even if I extend this line of action of the force, and if I draw the perpendicular from point B on this line of action, so this distance we can call as a perpendicular distance. Okay. So let us assume this distance as a distance D. So here 6000 into D, it will be a moment by the 6000 Newton force. So how to find out the distance D? So to find out distance D, this total distance AB, it is equal to 2.5 meter. So just add the distance 0.5, 0.5, 0.5 up to point B, it will become 2.5. Now we know this angle, this is equal to 30 degree. So this angle will be same. This is 30 degree. So D distance by using trigonometry, it is equal to, so you can find out this distance. So this is adjacent side of this right angle triangle. So it will become 2.5 cos 30. Okay, is it clear to you up to this step? How to find out the perpendicular distance for 6000 Newton with respect to point B? So if you have any doubt, you can ask. So now we will write the moment equation. So first we have to write down the left part of this Varignon's equation. So this is equal to summation of moment by all the forces about the point B. So this will be equal to, first we have considered 6000 Newton and we are taking the moment about the point B. So this is 6000, that is a force value, into its perpendicular distance, it is equal to 2.5 cos 30. And this moment, it is in the clockwise direction. Okay, so if you fix the point B and if you apply the force 6000 Newton, then that 6000 Newton force will rotate this complete system in the clockwise direction. And therefore, we have to take this as a minus 6000 into 2.5 cos 30. Now, similarly, take the moment by the force F. So, force F, perpendicular distance is not available. So, along this line distance is from point C up to point B, it is equal to 2 meter. So, to find out the perpendicular distance, so this will become the perpendicular distance. That distance perpendicular to the force direction. So how to find out this distance? Again, use the trigonometry. Consider this right angle triangle. Okay. So in this triangle, this angle will be 90 degree. So this diagonal, it is equal to 2 meter. And this angle, it is same. This angle, that is 30 degree. So this distance will be 2 cos 30. So take the second moment, force is F into perpendicular distance, it is 2 cos 30. And the direction of this moment, it is in the anti-clockwise direction. Okay, because actually this is the point C, this is the force F, and this is the point B. So along this CB, distance is 2 meter, and we are interested in perpendicular distance. So this is the perpendicular distance D, and that is equal to, this angle is 30. So it will become 2 cos 30. So this moment is F into 2 cos 30, and this force we'll try to rotate this beam AB in the anti-clockwise direction, and therefore it is plus. So similarly, take the moment by remaining forces, and all these moments are positive. So F into second is 1.5 cos 30 plus F into, now at point E distance will be 1 meter. So this is 1 cos 30 or only cos 30 plus F into, at point F distance is 0.5. So this will be 0.5 cos 30 . Okay, so find out this complete value. Put the value of F, that is equal to, so F value is 1226.25 Newton. Okay, so get this summation. Okay, so try to find out this value, summation of moment by forces about the point B, and then equate this value with the right part of the Varignan's theorem, moment by resultant about the point B. Okay, so by referring this diagram, this is the resultant system. So this is your resultant R, and we have assumed the distance along the line AB with respect to point B as x. So we want to find out the distance x, but by using Varignon's theorem, we can only find out the perpendicular distance. So let us take this perpendicular distance like this and draw one vertical line from point B and assume this distance as a distance d. So moment by the resultant so this part we will get from the last calculation. Now I will write the equation for moment by the resultant about the point B. So this is equal to your resultant is r into distance d is the perpendicular distance. Now this moment, it will be clockwise about the point B. So this will be minus r into d. Okay. So right now, the value that we will get for d, it is the perpendicular distance. And this is not the distance along this beam AB. So actually we are interested in finding the distance with respect to point B along the line AB. Okay. So first find out the perpendicular distance. So this is the d value. Just equate this value. So we will get this value left hand side from this calculation, summation of moment by all the forces about the point B. So put this value here. R value, it is equal to 1095. So this value, it is 1095 Newton. Okay. And get the value of D. So your answer, it will be a positive answer. So just verify this answer, whether you have got the same answer. Okay. So try to complete this part, do the calculation and just find out the value of D. So now we will solve one more example. So this is not on the parallel force system, but it is on the moment. So this is on the moment calculation. So note down this problem. A tow line, this is the problem statement. Tow line exerts a force of P is equal to 4 kilonewton. So this is the 4 kilonewton. At point B, at the end of 20-meter long crane boom. So this is called as a crane boom. If x is equal to 25 meter, so this is the distance x. So this is the point O, where the crane boom is connected to the trolley. Okay. And this horizontal distance, it is the x distance with respect to this point A that is fixed to the ground. Determine theta. So we have to find out this angle. Angle made by this crane boom with the horizontal axis. So this is the angle theta. So that the force creates a maximum moment about the point O. What is this moment? Okay. So we have to find out the maximum moment about the point O. For that condition, we need to find out the value of theta. That is the inclination of this crane boom with respect to the horizontal. So the crane boom length is given, that is equal to 20 meter. And this force in this cable, which is connected to the ground and the end of the crane boom, it is equal to 4 kilonewton. So first is, what is the value of the maximum moment? So can anyone tell me what is the value of maximum moment by this 4 kilonewton about the point O? For the maximum moment by this force 4 kilonewton about the point O, there will be only one condition, and that condition will be this line, that is line of action of this force, it must be perpendicular to this complete beam, that is the crane boom. Okay, so in that condition moment will be maximum. So I will just draw one line for this crane boom. So this line, it represents the crane boom. This is the point O, this is the point B, and this is the force, that is a P, which is equal to 4 kilonewton. If this angle is 90 degree, then and only then the moment by this force will be maximum about the point O. If you change this angle, just make it acute. And suppose this angle is obtuse. For both these angles, moment will be less than the maximum value. So maximum value will possible when this force is exactly perpendicular to this line OB. Okay. So therefore, maximum value of moment about point O, it is equal to, so I will just write moment by the force P about the point O, force P into distance OB. So force is 4 kilonewton into distance is OB 20 meter. So this will be 80, unit is force kilonewton and distance is meter. So it is 80 kilonewton meter. And this moment, it is in the clockwise direction. So this force will try to rotate this crane boom in this direction. That is a clockwise direction. So we will write this as a minus, and just we will represent the magnitude as 80 kilonewton meter, and this direction, it is in the clockwise direction. So this is the maximum value, and this maximum value, so this maximum moment will be produced when the force P is perpendicular to the line OB. So this is that condition. For this condition, if this is perpendicular, then the moment will be maximum. So this is the value for the second question, what is the maximum moment. And now we have to find out for this maximum moment, what should be the value of this theta. Okay, so up to this point is clear. What is meaning of maximum moment and how to find out the maximum moment. And now we have to find out the theta angle. So for the theta angle, we need to observe the dimensions of this boom, then the x distance and this distance 1.5 meter given with respect to this horizontal and the point O. So this is equal to 1.5 meter. So we will make one construction. Actually, we are interested in theta angle. We know this angle for this line AB, that is equal to 90 degree. We have this distance 1.5 meter and this distance x is equal to 25 meter. It is given in the problem. So just connect this point O to the point A. So from this construction, we will get two right angle triangle. The first triangle is AOM and second triangle is ABO. Now just concentrate on the first triangle AOM. So in this triangle, so this is the triangle. This is point A, this is point O, and this is M. So this is 1.5. This is X distance, that is equal to 25. We are interested in this diagonal value. So once we get this diagonal, then we can use a trigonometry or maybe cosine rule or sine rule in this triangle, and we can get the value of theta. Okay, so is it clear to you? So let us find out this value by using Pythagoras. So OA square, it is equal to 1.5 square plus 25 square. So from this we will get the value of the OA. So this is equal to, it is 25.04 meter. Just take the answer. Then we will find out this angle. So let us take this angle as a theta 1. Okay. So this theta 1 angle we can use to find out this complete angle. Angle of this boom OB with respect to this line AO. So we have to add this theta 1 to the theta. We will get this total angle because this theta 1, it is equal to this angle. Okay, these are the alternate angles. So let us find out theta 1 by using trigonometry. So theta 1 or tan theta 1, it is equal to opposite side, that is 1.5, divided by the adjacent side, that is 25. So it is 1.5 divided by 25. So tan inverse, you will get the answer. So this is equal to 3.43 degree. So this angle theta 1, that means this angle theta 1. Now consider this complete triangle OBA. So I will draw it here. This is point B. This is O. Okay, so in this triangle, OA length, it is equal to 25.04. So this is 25.04. This angle is known, that is equal to 90 degree. OB distance is given, that is equal to 20 meter. This total angle, it is equal to theta plus this theta 1. So let us take this as alpha, this total angle. Okay. So to find out this alpha value or to find out this theta value, okay, we will use this sine rule. Sine rule for a triangle. So what is sine rule? If you have one angle, okay, and if you have two sides, then we can find out the remaining angles and remaining sides by using the sine rule. So sine rule is this side OB divided by sine of opposite angle is equal to side AB divided by sine of opposite angle. It is equal to side AO divided by the sine of opposite angle. So I will write this statement. OB divided by opposite angle. So this is the angle. Okay. So let us take this angle as a theta 2. So we will write this sine theta 2. It is equal to side AO. Its opposite angle is 90 degree. So this is sine 90. It is equal to side AB divided by its opposite angle, that is alpha. Okay. So here this OB length is given, that is equal to 20. Okay. Then OA, this distance is known. So that is equal to 25.04 and this distance is known. Okay. So we can get the value of sine theta 2 or we can find out the theta 2. So I will write here OB divided by sine theta 2. It is equal to AO divided by sine 90. Okay. So just put the values. OB is 20 divided by sine theta 2. It is equal to AO. This value is 25.04 divided by sine 90 is 1. Okay. So get the value of sine theta 2. So sine theta 2, this is equal to 25.04 divided by 20. Sorry, this is 20 divided by 25.04. So theta 2 you will get as 53 degree. Okay. So you have got this answer, theta 2. So this is equal to 53 degree. Now this total angle, this will be 180 degree. So to find out this alpha value, alpha is equal to 180 minus 90 minus 53. Okay. So your value will be 37. This is the value of alpha. And to find out the theta value, so question is we have to find out this theta value. Okay. So theta 1, we have already calculated value. Okay. So this value is 3.43. So your theta plus theta 1, it is equal to alpha. So theta 1 is 3.43. So theta is equal to 37 minus 3.43. So you will get the value. Theta is equal to 33.57. Okay. So I hope you have understood this problem. So mostly this problem is depending on the trigonometry and the sine rule. So you have to remember this rule. So you might have studied this rule, maybe your 11th or 12th maths. So is it clear to you, this complete problem? So for the previous problem, which is on the excavator arm, okay, so I will show the simulation, how these forces will cause the movement of this arm. Then you can understand the practical application of this calculation, resultant and its location. So just check whether the screen is visible to you. Is the screen visible? So in this simulation, the forces F, 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 and F acting at 4 different points, and the cable tension will act at this point. That is the end point of this arm. So you can see these forces. These are 4 forces. And you can see the upward movement. So this is the tension in the cable. So it is slowly moving in the upward direction. As it is moving in the upward direction, that means this movement, it is in the clockwise direction about this point. Okay, so I hope this point is clear. The application of the resultant and the moment. So I will again run the simulation. So this is the tension, and these are the 4 forces. So whole arm is rotating about this point. So you can use the engineering mechanics for most of the practical problems. So if you understand the practical application of this subject, then you can understand the subject engineering mechanics. So on this lever, the force of 50 Newton acting at 60 degree. Second is 100 Newton acting in the vertically downward, and 120 Newton acting in the horizontal direction. Okay. And we have to find out the resultant of this force system. So what is the value of R and its location with respect to point B. So to find out the R, we will follow this step. First, we will resolve the forces. For the resolution, we have to only consider the forces which are acting by some angle with respect to x-axis or y-axis. And if the forces are exactly horizontal or exactly vertical, no need to resolve the forces. And therefore, only we will resolve the 50 Newton force. So for the resolution, in case of general force system, just remember one point. When the force acts on a lever or on a beam, then resolve the force only at the point of contact. So this is the point of contact of this force with this lever. So resolve the force at this point only. So I will show the resolution. So this is the point of contact of this force. So from this point, draw one vertical line and draw the horizontal line. So along this vertical line, we will have the y component like this. And along this line, we will have the x component. So as direction is given like this, so we will show the forces that is a component in the same direction. So this component, it is the adjacent component because angle is given with respect to this component. So this will be 50 cos 60. Adjacent is always cos, and this will be opposite. So this will be 50 sin 60. 100 Newton is y direction and 120 Newton it is in the x direction. So second step is we have to find out summation fx. So that is equal to 50 cos 60 . There is no component of 100 Newton in the x direction. So only we have to consider this 120. So plus 120. So we will get this answer as a 145 Newton. As it is positive, that means it is positive x-axis. Then find out summation fy. So for the summation fy, this 50 sin 60, it is in the negative y direction. So this is minus 50 sin 60 minus 100 and no component of 120 in the y direction. So this value will be minus 143.3 Newton. As it is negative, that means it is 140.3. This is the magnitude acting in the negative y direction. So this is the direction. So we need to use this direction when we will locate the resultant. So for the location, we first know what is the quadrant, okay, and then we have to find out the angle. So can you tell me the quadrant of the resultant from summation fx and summation fy? Yes, you can give your answer in the chat box. What is the quadrant of the resultant? So what is meaning of summation fx? It is nothing but the x component of resultant, and summation fy is the y component of resultant. So if resultant is r, so first we will find out the resultant. Yes, it is the fourth quadrant. So from this fx and fy, we will find out the resultant by using this formula. Fx square plus summation fy square. So this value is 203.8 Newton. Now locate the resultant. So we will assume the resultant acting in the fourth quadrant from this summation fx and summation fy. So this is the resultant direction. This is summation fx. This is summation fy. And this angle is theta. Okay. So theta we can find out by using this formula. Tan inverse summation fy divided by summation fx. So when you use this formula, just consider positive values only because we already know the quadrant of the resultant. So just we are interested in this theta value. Okay. So put the values 143 divided by 145. So you will get the theta value as 44.66 degree. So this angle is 44.66 degree. Okay. Is it clear to you up to this step? If you have any doubt, you can directly ask. So now next step is we have to find out the location with respect to B. So right now we have got the resultant 203. Its angle is 44.66 with respect to x-axis. Okay. And we know the quadrant, it is in the fourth quadrant. So now we have to locate this resultant on this diagram with respect to point B. So I will draw the beam. So this is the point B. Okay. Now we know the resultant. It is in the fourth quadrant like this. This is the angle theta and this is the R. So there is possibility that resultant may be on the right side of the point B, or resultant may be acting in the left side of the point B. So right now we don't know whether it is on the right side or it is on the left side. So just assume resultant is acting on the right side and direction must be parallel to the resultant direction. So this is the resultant R, that is equal to 203.8 Newton, and this angle with respect to x-axis, so this is the angle theta, it is equal to 44.66 degree. So when we locate the resultant, just draw the parallel line to this resultant only. So somewhere draw one reference axis, show this resultant, and then draw this figure. And now we have to locate the resultant. That means we have to find out the distance of this resultant along this line, okay, or along this line. So this line is AB and this line is BC. So first we will find out one perpendicular distance. So draw perpendicular from point B on the resultant like this. And this is the perpendicular distance. So why we are assuming perpendicular distance only? Because by using Varignan's theorem, we can only find out the perpendicular distance. Okay. So now we will use the Varignan's theorem. So summation of moment by all the forces about the point B is equal to the moment by the resultant about the same point B. So first find out the left part. So for that we have to observe the complete system of forces. So we'll get this left calculation by referring this diagram. Okay. So this is the first force. We have resolved that force into two components. This is second force and this is the third force. So moment by this 50 sine 60, it will be 50 sine 60 into this perpendicular distance. 0.2 plus 0.2, that is 0.4. Moment by 50 cos 60, it will be 0. Why it is 0? Because this line of action, it will pass through the point B. So perpendicular distance will be 0 as the force is passing through the point B only. So moment by this force will be 0. Then moment by 100 Newton, it will be anti-clockwise, that is positive. So 100 into 0.2. And moment by 120, it is clockwise and the moment will be 120 into perpendicular distance. So 0.4 is not perpendicular distance. So we need to find out perpendicular distance. So just extend this line of action like this. So this distance, it will be a perpendicular distance. So how to find out this distance? 0.4 is diagonal. This is 30 degree. So this distance will be 0.4 into cos 30. So this will be adjacent side in this triangle. Okay. So 120 into 0.4 cos 30, and this is clockwise. Therefore it is minus. Okay. So at this moment, this will be summation of moment. So I will write this for summation of moment. First is 50 sine 60 into 0.4, moment is positive. Second is 100 into 0.2, again this moment is positive. Next is 120 into 0.4 cos 30. This moment is negative because the force is acting here and this will create the clockwise effect. It is equal to moment by resultant about the point B. So this is our assumption. Resultant is acting on the right side. So we will take this moment. Resultant value is 203.8 into distance D is the perpendicular distance. So right now we don't know what is the value of D. By using Varignan's theorem, we will find out this value D. So put this value D as it is. And this moment, it will be clockwise. So this is minus. So if you solve this complete equation, we will get the value of D. So D is equal to This is 2.08 meter. And how to decide whether our assumed direction is correct, whether it is on the right side or left side? If the value of D, if it is positive from this calculation, then our assumption is correct. Okay, because distance cannot be negative. But suppose distance is negative, that means your answer is correct, but resultant has to be on the left side. Okay, so this is the difference. So right now our value is 2.08. This is centimeter. Okay, so actually you will get the answer as 0.208. Sorry, 0.0208. This is in meter. Okay, so if you convert it in centimeter, you will get 2.08 centimeter. That means we have got this distance D. Now we have to find out distance along the line BC, where this resultant will cut the line BC. Okay, so for that, this is the lever, this is point A, this is point B, and this is the resultant, like this. With respect to point B, we have got this perpendicular distance. Okay, so this distance is D. Now this angle, it is 44.66. Now we have to find out this distance. So let us take this point as a point N. So BM distance, take this as a X. So this triangle will be a right angle triangle. This is B, this is M. Okay, let us take this point as a O. So this is 90 degree. This will become a diagonal. So this is X. Okay, we know this angle 44.66. So from this angle, we can find out one angle, either this angle or this angle. Okay, so if you construct a line like this, so this total angle is given. So this is equal to 60 degree, this total angle. Okay, so this angle is 44. That means this angle will be same. This is 44. Okay, so this is 44. This is 90 degree. So we can find out this small angle. So once we get this small angle, we can find out this angle. So 44.66 minus 90. So it is 45.34. This small angle. This is 45.34. Okay. And total angle is 60. So 60 minus, it is 14.66. So this angle is 14.66. So this angle, it is 14.66. So now you can easily find out X side. So X will be this OB, it is known as a D. So D divided by cos of 14.66. So X is equal to, this is 2.08 centimeter divided by cos 14.66. So just you can get the answer. So it is 2.16 centimeter. Okay. So I hope you have understood this calculation. Now I'll just show this simulation, how these forces will cause the rotation of this complete system. So this is the system. This point is A. This is the B point, that is a hinge point, and this is the C point. So you can see the forces and their effect. If the resultant is acting on the right side of the B, then it will rotate the system in the clockwise direction. And if the resultant acts in the left side of this point B, it will rotate the system in the anti-clockwise direction. So we will check the effect, whether it is on the right side or it is on the left side. So this is the resultant, and these are the forces. So all these forces are resultant. As it is acting on the right side, it will rotate the system in the clockwise direction. Okay. So I will run the simulation again. Just observe the direction of the resultant. So this is the resultant, and this distance, it is 2.08 perpendicular distance, and along this line, so this distance, it is equal to 2.16. So you can see the effect of that resultant. It will rotate this complete lever in the clockwise direction. Okay, so I hope this problem is clear. If you have any doubt, you can ask. Otherwise, we will stop here. So just give your attendance in the chat box.